Okay, so what's been calibrations of the eyepiece graticule? Okay, in this topic. Now, before I go into this part, calibration of eyepiece graticule for today, don't need to copy down. It's recorded. 1 second. I will allow you guys to take the photo later. Okay. So calibration of eyepiece graticule. Before we continue with this part, very, very simple. If I have something, let's say an object. If I give you a ruler, you are very simple, right? You're very simple. If I give you a ruler. Okay, understand the concept, huh? So, okay, if I give you a millimeter ruler, so what you need to do, you straight away use this millimeter ruler and measure. Okay, you put the object here. You align, and then you measure. Now, why you can measure? Because the millimeter ruler already have a scale and also the unit. What's mean unit? You do know that this is 1 mm, 2 mm, 3 mm, 4 mm, and so on. Correct? You already know each divisions here is 1 mm. Clear? You can measure, right? But now I didn't give you a millimeter ruler. I didn't give you a millimeter ruler. I give you a special ruler. Okay, this is the special ruler that I make it myself and got a scale. Apparently, you can see that both ruler actually have different scale, correct? Are you clear? And I didn't tell you what is the scale, what is the unit of the scale. How many unit? I didn't tell you. So if I didn't tell you what you need to do, basically, first thing you need to do a calibration. Correct? This is the first step you need to do because I do not know each unit here, each one. Okay, from here to here, 1 mm, 1.5 mm, or 0.5 mm. We do not know because this is a special ruler that I made and I didn't tell you what is the unit. So you need to calibrate. How you need to calibrate? You need to calibrate by using a millimeter, that something that you know, to calibrate so that I know what is the unit of one division here. Therefore, I can use this special ruler to measure. Are you clear? So this is the problem that we're going to face if we use the microscope. Why? Because in the microscope, we have these two things that you need to know. One is eyepiece graticule, another one is a stage micrometer. So from the name eyepiece graticule, eyepiece basically means that we place this ruler or graticule near to the eyepiece. Okay, so let us look at the structure or the component of the microscope. So you have this the tube. So this tube, you have two lenses, correct or not? So one is the eyepiece. Okay, another lens, we put it at the bottom here. This is the objective lens. Correct or not? Objective lens. Okay, then we have the stage. Correct or not? We have a stage. Okay, so when you place the specimen, okay, you place a specimen and view the specimen. Okay, when you view the specimen, so what you're going to have here is, you saw, okay, the diagram. Let's say, for example, okay, 1 special and 9 cell. Okay, this is what you view, okay, under the light microscope. Okay, so what you're going to do, okay, you're going to draw it out, okay, on a piece of paper. Let me show you something, yeah. Okay, so this is what you view, and this is what you draw on a piece of paper. Correct or not? So you view and you draw. So Very, very obvious. You already magnify it. Correct or not? You already magnify it. Correct or not? So the question here is, if you want to calculate what is the magnification of your drawing, you need to know what is the length of the image or drawing divided by the actual length. So in this case, no problem. I always can measure my drawing, okay? Let's say, for example, from here, okay, until here. Right, so I can always measure the length in millimeter. How many millimeter? Correct. But how I can measure my actual length? I know that this is our actual length. Correct not? So how I know my actual length? You cannot place a ruler, right? Correct not? So in order to measure this actual length so that I can calculate the magnification, then I need to use a scale here. So this scale, this is something like a ruler, the scale is placed under eyepiece graticule. And so it's placed under eyepiece and it's called eyepiece graticule. You have the scale. So this scale is known as eyepiece graticule. Are you clear? It's eyepiece graticule. And unfortunately, eyepiece graticule, the unit is not constant. Now, why unit is not constant? Now, let you guys see a picture here, yeah? So if I have a scale like this eyepiece graticule, EPG, eyepiece graticule scale. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 scale. Okay? Because we have 3 different objective lengths normally. Okay, 3 objective lenses. So what will happen here? Try to imagine, because eyepiece, eyepiece graticule, we place it under the eyepiece crown. So means that eyepiece graticule will be enlarged by eyepiece, but it won't be enlarged by objective lens. So means that you change the objective lens from 4 times to 10 times to 40 times, the magnifications of the eyepiece graticule remain the same. It won't change. Are you clear? Right. Because if you use a more higher power of the objective lens, you are going to enlarge the object here, but it won't enlarge your eyepiece graticule. Whatever you see the eyepiece graticule is only enlarged by the eyepiece only. So that's why every time you change the objective lens, then you have to recalibrate the eyepiece graticule again. Correct or not? Okay, this is what you're going to see. Okay, this eyepiece. Okay, let me do something. Now, this eyepiece graticule, and duplicate it. Now, look at this. If I use, okay, my objective lens 4 times, okay, my salt will be something like this. Very small, right? 4 times only my salt. Okay, but if I change it to 10 times, again, eyepiece graticule, will it change? It won't change because it's magnified by who? Eyepiece only, right? Objective lens, how I change, it won't affect the size of my EPG eyepiece graticule. So means that now my cells become bigger, but my eyepiece graticule still remain the same. Can you see that? So means the eyepiece graticule, we cannot give a definite unit to my eyepiece graticule. I have to calibrate it before I use it to measure the actual length of the cells. So how we're going to do this, we need another item known as the stage micrometer. So to do the calibration, okay, to calibrate that just now, right? You need to calibrate the unknown ruler. You have to use a ruler, right? The actual ruler. So to calibrate the eyepiece graticule, we need, okay, a stage micrometer. So from the name stage micrometer, we know that we're going to place it on the stage of the microscope. Are you clear? We're going to place on stage. So when you place on the stage, now look at it again. This is the eyepiece. This is the objective lens. As I said, that's where you place eyepiece graticule, you're going to place eyepiece graticule somewhere here. Okay, so this EPG, eyepiece graticule. And on the stage now, you place this stage micrometer. So how the stage micrometer look like? It's just like a glass, something like this, the glass. Can draw it three-dimensional. With the scale onto it. Are you clear? With the scale onto it. So this one, when you purchase the stage micrometer, so you look at the scale. So the company that you purchase will tell you what is the length of one unit or one division. Normally, this will be 0.1 mm for one division. Are you clear? So this one is something like our normal ruler. The normal ruler that we can use it to calibrate my special ruler. Are you clear? So we view it under, okay, can you see that? Now we view it under the microscope, and then you're going to see that's now two scale. One is the stage micrometer scale, another one is EPG. So those both scale will overlap now, correct or not? Right, they will overlap. So what you're going to see, it will be something like this. So first, you're going to see this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 0, 10, 20. Okay. Now you can see that one is very thin line. One image with a thin line, another image is with the thick line. Example, thick line. So thin line and thick line, now you can see that both of them, they are overlap. Okay? They are overlapping with each other. Thin line actually, because you can imagine that, guys, we have eyepiece graticule and stage micrometer. Thin line will be the eyepiece graticule. Why eyepiece graticule? Because we enlarge only one time. By who? By eyepiece. But stage micrometer, the scale will be enlarged by objective lens and enlarged by eyepiece. So it means that 2 times enlargement. So you can see that the thick line actually is a stage micrometer. Thin line actually is from the eyepiece graticule. So what we're going to do here is we make sure that now the line actually line it well. We align it. Okay, so this is 0, this is 1, this is 2. We align it nicely. So how we align? We align the first line and the last line. This is how we align. Align the first and the last line. Once we align already, these 2 lines is called as the coincident lines. Okay, so this is first coincident line. Okay, so we have last and first coincident line. And then we start to count how many eyepiece graticule smallest division we count. And how many stage micrometer smallest division. Okay, so we do this. Okay, so once we have this already, now what we're going to do, first step, number of eyepiece graticule, smallest division. Okay, between two coincident line. How many? So you count. So 1, 2, 3, 4, 5, 6, blah, blah, blah. Oh, 20. 20 smallest division. Okay, step number 1. Step number 2, we count number of stage micrometer smallest division between two coincident line. Okay, equal to how many? 1, 2. So 2 smallest division or 2 division. Now, third. So what is the length or distance between? Okay. So distance between two coincident line. What's the distance? If I know the stage micrometer, every divisions, let's say the company tell me it's 0.1 millimeter. So what is the distance between these two coincident line? So 0.1, 0.1. So means 2 times, right? So 2 stage micrometer smallest division multiplied with 0.1 mm. So I know it's 0.2 mm. Correct? Are you clear? And normally we're going to change to micrometer. So 0.2 micrometer, how to change? Multiply with 1000, you get micrometer. So actually distance between two coincident line is 200 micrometer now. Correct or not? Okay, so once we know this already, very simple. So if I know these two, okay, smallest divisions equivalent to 0.2 millimeter or 200 micrometer, so means that 20 units of my eyepiece graticule smallest division also equal to the same length, correct or not? Okay, so now step number 4. So the length of 20 eyepiece graticule smallest division equal also to 200 micrometer. So I know now the length of one eyepiece graticule smallest division will equal to 200 divided by 20. So therefore I know it's 10 micrometer. So I already done the calibrations already, right? Now I have done the calibrations. Now I know that each division is actually, just now how many I calculate? 10 micrometer. Can I see that? 10 micrometer. So what's my next step? Next step, very simple. I already done the calibration already. I remove, okay? I remove my stage micrometer. So the next part here, what I'm going to do here, okay? So this is my scale. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And I remove the stage micrometer, but I cannot remove the eyepiece graticule. It's already mounted at this my microscope there under the eyepiece. So it's that I cannot remove. I only can remove my stage micrometer. So then I can view. I can place my specimen. Oh, I see this. The cell. So now, how many? 1, 2, 3, 4, 5. Oh, 5 divisions. So what is the length of the cell? So the length of the cells will equal to 1, 2, 3, 4, 5. 5 eyepiece graticule smallest division, and each division is 10 micrometer. Now I know the length of the cell is 50 micrometer. This is the actual length. Can you see that? Do you get the idea so far? Okay or not? Are you good? Okay, so I stop the recording now. I've done the eyepiece graticule